All right, so our first April TOC meeting, we have 2 items on the agenda. I suspect once we open the multi-cluster design discussion, we may not get to anything else, and I want to make sure that we get to Daniel's item. Daniel, did you want to chat with us about our needs for a tertiary release manager?
I just wanted to make sure that I'm not missing anybody because the branch cutting starts Wednesday. So if there's a tertiary, I'll make sure they get involved. But as last I heard, they're still looking for one.
And the tertiary's role is mostly educational for this release, with the idea that they take on a larger responsibility in a future release. Is that right?
That's correct. Yeah, it's a learning opportunity.
I might have somebody give me today and tomorrow to chat with them, and I will let you know if they're on board.
I appreciate it.
I'd ask for others, but it looks like we only have the 2 companies represented today. Okay, so I guess we can open the multi-cluster L7 design discussion. This is a bit of a reopening of a question in some sense. We had the multi-network ambient protocol doc was approved, I want to say, in December. And this was moving towards multi-cluster for ambient. We have an outstanding design doc around control plane implementation for multi-network ambient. And as we were discussing that design doc, we realized that we had not paid sufficient attention to a question in the protocol doc. When you have L4 routing in multi-cluster, L4 only routing, that is, there are no waypoints involved in either the client cluster or the destination cluster. Routing is really simple. The local Z tunnel has to make a global routing decision. It traverses an east-west gateway with an outer H-bone tunnel, and then sends a second H-bone, essentially HTTP connect request, which the east-west gateway load balances to a back-end Z tunnel for the particular pod that will terminate the traffic. Gives us full end-to-end MTLS, gives us multi-cluster routing with L4 failover, which is of some usefulness, but maybe not maximal usefulness. And it prevents global knowledge. The local Z tunnel doesn't need to know how many remote Z tunnels or possible destination pods there are, what their IP addresses are, et cetera, et cetera. So that model is pretty well established, I think. But the question comes into play when we introduce a waypoint. Waypoints apply several bits of L7 sort of policy and other configuration. And we started asking questions about these configs. We really broke it down into routing and extensibility, auth policy, and then outlier detection. I suppose telemetry might need its own category in there. I haven't really given much thought to that. But for each of these, we asked the question, like, order of operations, where should this execute? How do we sort of fit in with what already happens today in single cluster mode so that we're not inventing something entirely new? Then questions about where the controlling configuration should be. Should I configure an L7 feature from network, from my destination cluster or from the client-side cluster? And then lastly, and associated with where the config should be, maybe even identical to the question, is where should it execute? So if we have our order of operations, we know which cluster should control. How do we build our infrastructure model to support those decisions? We've had a lot of healthy discussion on the topic over the weekend in the doc. I was really hoping to get Louis' input on this today. He has a way of solving these problems very elegantly. But we've outlined in the doc, or I've attempted to outline in the doc rather, sort of the decisions or the requirements that we have along the way. For instance, like outlier detection has to take place in the source cluster. It might also happen again in a destination cluster, but certainly at least in the source cluster. Oh, hey, Louis.
Hey, folks.
Routing and extensibility is really where the question lies in terms of order of operations, etc. And then authorization and authentication follow the rest. So the conclusions that I came to are sort of listed here in recommendations. I don't think we have consensus on those conclusions. I feel like there's a way to tell a story why we must do L7 routing on the server side, and there's a way to tell a story why we must do L7 routing on the client side. Obviously, we can't do L7 routing twice. So one of these requirements or principles that we're trying to sort of follow with this, we're going to need to bend on. And the question is, which one is the best one to break? John, I saw you had a comment about that this is sort of has a different focus than the protocol doc, I think is what you're saying.
Yeah, I don't think it really matters. I was just trying to state that it wasn't like we approved something and didn't think about it on the protocol doc, or at least that wasn't my intent. It was more just that the protocol doc didn't address this, and it was just about the HBone protocol. If we are to send to a waypoint, how do we do that? Which we haven't changed. It's just a question of how do we decide whether or not we even send to the waypoint, and things like that.
Gotcha. Yeah. So maybe the best way to discuss things are the two stories of why we can't do either. And I've mentioned to Keith, I feel like the guy in The Princess Bride, I clearly can't drink the wine in front of you, and I clearly can't drink the wine in front of me. The problem with local routing is that you may make a routing decision to a service that doesn't exist in a destination cluster. Sorry, no, that's the problem with remote routing. Oh, it's also hard to keep these problems straight in my head. So you can imagine the situation where a client makes a request. zTunnel either says I don't have that service locally, or perhaps it's not healthy, has been having some outlier behaviors. So we choose a remote cluster to route the service to. In that remote cluster, the request goes through L7, through a waypoint. And during waypoint routing, we can effectively change what service the request is destined for. We can modify the FQDN, we can modify the path, we can do weighted routing, all sorts of stuff. So we sort of think of L7 routing as like a black box where we put an L4 request in the front and we get an L7 request in the back. Sometimes they may have a one-to-one relationship if like while we're doing is auth policy. Other times they may bear no apparent relationship to one another. It could appear to be more or less random from an L7 or L4 perspective. And it could be that waypoint chooses a service that does not exist locally in the cluster, or that is not healthy locally in the cluster. Probably the health, I'll say Mike Morris has been careful to point out that Gateway API does not allow the creation of routes to services that don't exist in the cluster. It's effectively a local routing protocol or API. So I don't want to say service. I'm going to try to catch myself when I say services that don't exist locally. What I really mean is services that aren't healthy locally. Maybe there's 0 instances running. Maybe there's a local outage. Who knows? So in this scenario, a request started in the client cluster. It's landed in a remote cluster, but it's a remote cluster that cannot satisfy the request. And then we would need to route to yet another cluster. And that presents the difficulty of then, do we respect that cluster's L7 config as well? If we do, we've got some double L7 processing concerns. L7 processing is not idempotent. You cannot reapply it to one request without destroying information. Sometimes you can incidentally, but you cannot always reapply it. Or do we bypass that other remote cluster's L7 auth? We run into problems. So one possible solution to this is do all of the L7 on the client side. I'm going to wave my hand about infrastructure concerns for this right now, and where does the waypoint live, etc. We can get to that, but just from a logical perspective, we can do all of the L7 processing before the traffic leaves the cluster. and have the L7 processing utility make the global load balancing decision. Should this land in an L7 service or L4 service that is here in my cluster or remote? And then if we were to go remote, we would not respect the remote waypoint. We would be bypassing it.
So Mitch, just on that principle alone, right? I think you fall over, right? Pretty much immediately, right? Like trying to guarantee that we always do L7 processing locally, when even the definition of local is so fluid, right? In what a service mesh does.
Yes.
Right. You can kind of take the conceptual viewpoint. Look, who cares about local, right? There's just a network. Everything's on the network. And we're going to go through a waypoint, right? That's relatively easy to reason about, right? And that's how we have done things in the past, right? That's how we have always done things in the past in Istio. It was a facility, I guess, or it was made easier by the virtue of sidecars, but logically, that's kind of what we did.
Sure.
When we start saying processing by locality, which is convenient and important for performance standpoint, but it's very hard to provide structural guarantees around, right? Like, given that waypoints are bound to the producer of the service, right? Generally speaking, the producers may never exist in your local cluster, so we could never guarantee that we could process them.
Yep.
And even maybe, I don't want to get into like knowledge existence problems, right? Where, you know, even the existence of a waypoint in your local cluster for something you're not supposed to know about is problematic.
Yep.
Right. Like, I'd rather just not go down the rabbit hole of all those things. Our functional requirement is we go through a waypoint once, right?
0 or once.
0 once. If there is a waypoint for a service, we must go through it.
Well, becomes a problem when we don't know about locality, but yes.
And yeah, even that, like, any knowledge problem, right, across an eventually consistent config distribution system with imperfect knowledge is by definition imperfect. Z-tunnel may choose to go to a cluster that's may have a waypoint and may choose to go to a locality that does not have a waypoint. And whose fault is that, so to speak? So we can either try and, like, I think trying to get to complete consistency is just inherently problematic.
Oh yeah.
We can provide guidelines to people about how they can achieve consistency. And then we should provide a simple solution that works well in most cases and be able to document the outliers. Right? Eventual consistency being one of the outliers, knowledge horizons, partitioned configuration domains, right? Like eventual, just all the eventual rollouts you're going to run into in a giant network, right? Which is something we support. Yeah. So, like, what is the pragmatic solution that doesn't require a heinous amount of consistency in config distribution or knowledge to function? Like, let's say, as a basic principle, everywhere you deploy a service, the waypoint is consistent for everywhere that service is deployed.
Mm-hmm.
As an operational guide to the user. What is the simplest system that works with that type of recommendation? That's probably what I think we should be aiming for. So we have those two requirements. Okay, so we must go through the waypoint if there is a waypoint in that locality, which if you have in the destination locality, and if you meet the requirement of the destination localities are waypoint consistent, then I think we have a simpler problem to solve. Keith, give your hand up. I don't want to keep jammering on.
Yeah, so a couple of things. One, on the waypoint question, I think, or specific, me to be more specific, on the question of what if Z-tunnel goes to a cluster that does not have a waypoint for that service, I think that's actually solvable. If we load balance across waypoints in the system for the service, I think we can solve that in the control plane. But we can get to implementation detail later. The thing I want to focus in on is that requirement that you only go through a waypoint once. I think that that's sort of how we've been thinking about the problem up until this point. But I added the section on exploring trade-offs, and I think it might be possible to relax that requirement and get to a place that is both pragmatic. It's sort of you still get some level of correctness in most cases, but in those cases where, as Mitch mentioned, where you don't have healthy endpoints in the destination cluster, we might be able to help the user, so to speak, and fail over to a healthy cluster in a way that's not heinous, to quote you, Louis. So just want to maybe double click on that requirement. How married to that requirement are we? If we could practically figure out how to avoid double policy, are we still married to that requirement?
It's a pretty important requirement, right? We know that cascading failure is a feature of double policy, right? A retry of a retry, or a retry of a timeout, or a timeout of a retry, right? We've seen it so often in the industry that, we're reasonably terrified of that, I think.
Yes, agree with double policy, but what if we could have, I buried the lead a bit. I'll skip ahead a little bit to say, I feel like as we talk about these things, there is some useful subset of these problems that have been solved in sidecars, right? We don't apply all the retries in the client and all the retries in the server. There's a split. We've come up with a heuristic that is reasonable.
Yeah. So, load balancing twice is usually fine, for instance, right? But double auth may not be, right? Because you may do credential stripping, right? Very common. So
potentially, yes.
Right. So things that affect traffic scale or access generally not so good, but hierarchical load balancing is usually fine. Routing is risky, right? So it probably belongs in the first bucket.
Yeah.
That doesn't mean that going through a waypoint twice is problematic. It means applying the policy twice is problematic.
Right.
Exactly. And that's sort of the spot I want us to end up. I think we have a similar problem in the sidecar interop case, right? If you have a client, even in single cluster. So for just strip out multi-cluster, if you get a client sidecar sending to a server waypoint, if I'm not mistaken, it's still problematic for both sides, for the waypoint to apply all of its policy. Is that true or false?
It depends what we've told the sidecar to do, but
yes. If you're just coming from a vanilla sidecar Istio, not vanilla, but a typical sidecar Istio world, you might have a policy to do routing that the sidecar will apply, and then you go to the destination waypoint, and it also might apply routing, or a path rewrite or something like that, and that would be problematic. Am I missing something?
No, that would be problematic. I think we'd have to tell one of those two things not to do it.
Yes, and yes, and so in my mind, that this sort of spillover problem, if you get to a destination cluster and there is a waypoint for that cluster, and after that waypoint does L7 routing, there's no local healthy endpoints in that cluster. I'm wondering if it's feasible to allow that waypoint to go off box for more time. But when it goes off box, off box is a loaded term. When it goes to a different cluster, if we have that waypoint act as a client sidecar, right? It's applied some policy. And so when another waypoint receives that traffic, it treats it as if it originated from a client sidecar. So that's phrase.
Yes, it basically provides an instruction telling it don't do non-safe policy things, because policies have already been applied, right? So we're marking it.
Yes, and we can talk about how to do that. You can do things with baggage. We can maybe go back to our ALP and hacks. We'll figure out what that signal looks like. Veto.
Immediate veto.
I think the problem there, Keith, is that it doesn't sound like we can make a reasonable decision about local service health before having done, say, routing.
Envoy just doesn't work that way. So
Yeah.
Downward.
So which pieces can we reasonably defer until after we've selected an endpoint?
And that's the key, and that's why I wanted to amend my statement slightly. It's not that the client waypoint is doing less. I don't know that we can reasonably do that, to your point. It would be that, I guess my question is, if we have the client sidecar waypoint do all of its policy, and then send to a server waypoint. And again, in this case, this only happens if you're going to a different service after doing L7 routing in that client waypoint. If that client waypoint sends to the server, to a server waypoint in a different cluster, and that server waypoint does a subset of its policy that we feel is safe, or that is safe, or is typical of what a server sidecar does, is that subset of policy useful enough for us to go down that road?
Well, I think what we've heard is that would just be load balancing, right? We can't do routing. We can't do auth.
I'm curious about the auth. Like that's really the piece, because I feel like auth itself, like I feel like that would be the minimum useful subset of policy to execute. Otherwise, you're that client sidecar becomes a bypass, in a man in the middle into whatever.
Like request auth or L4 auth, right? We have to separate those two.
Look, L7 auth, but like no delete requests. That sort of auth.
Right. So authorization policy, not request authentication.
Yes.
Yes. So auth-z, yeah, I think I would generally agree at a course level. Both they have to compose, and that might be dangerous not to compose because we don't want trampolines. But things like JOT, like request authentication, JOT rewriting, JOT expansion, definitely not.
Absolutely. Yeah.
Now there may be some funky edge cases in there in the auth-z case that we have to make recommendations to people to allow or disallow. And how they compose. But that seems like it should be tractable, but it might take a little effort to write those rules down.
Yeah, sorry, I've skipped ahead. I didn't mean to sort of hijack, but I the whole beginning of this was just I wanted to drill down on that requirement of not going through two waypoints to see is that really the requirement, or is the requirement we don't apply unsafe policy twice? And it sounds like we're in the latter category, but the requirement is that we don't apply unsafe policy twice.
Yes, that is definitely the functional requirement. There's no unsafe policy twice.
So in my mind, Louis, the idea that we always traverse, do some or all L7 processing server side if a server side waypoint exists, combined with a requirement that most of L7 cannot be safely done twice, would mean that once traffic has traversed an L7 processor, it generally can't be multi-cluster routed again. Routed out of cluster, it must stay in the local cluster or fail.
Even that, I don't think that's a hard requirement, right? Like you obviously don't want to end up in a loop,
right?
So like we talked about marking the traffic, right? That's probably a feature of the marking to decide, like what is the allowable depth, right? This is just like exported.
We can route to another backend, assuming that all of the services have a consistent L7 policy view, then it really doesn't matter. We don't need this. We need a server side to do the L7, not the ultimate server side to do the L7.
And that's the organizational constraint, right? Which is everywhere that you have the waypoint for X, it must be the same. So you don't have inconsistent policy. Any policy you're applying is item that we allow or decide to allow, like the L7 auth-z stuff, is item potent, to figure out what that is. then they're just local load balancers at that point, effectively, not routers. And yeah, we have to evaluate the operational and runtime complexity of implementing such a system. But I don't think it's a hard requirement that we don't allow multi-hop.
The only problem with the assumption of L7 being consistent is global or regional rollouts.
Right. Yeah. So we have to tell people, right? Our assumption is that L7 is consistent. This may not be the case for these reasons, and you should just be aware that these can have an effect, right? If you roll out a change to one cluster but not to others, they have different policy. If traffic for any path ends up in those places, different things will happen, whether it was one hop or two.
Okay.
Right. That's not any different really between single cluster and multi-cluster. Right. We already have we have that property, no matter what. So people are used to that. You know, they should probably have tooling that tells them that cluster A and cluster B are not quite the same for this at this point in time. But we absolutely do that to people today. They do it to themselves.
Well, I think the delta tends to be quite a bit smaller in terms of how long that difference exists, as opposed to rollouts can sometimes be days or a week-long sort of operation.
In companies with hundreds of clusters, those rollouts are measured in days and weeks.
Yeah.
Often. So what the counterbalance to that, right, is good messaging, right? Good status, good error reporting, good logging, right? That's the universal antidote to why is my system behaving differently, and that is for everything just everything actually. So I don't think we should try and do more than that.
So if I may ask, it sounds. Oh, go ahead. Sorry, I thought you were.
No, go ahead, Keith. I was gonna recapitulate my point. Go ahead.
Okay, I was gonna ask. It's sounding like at least Mitch and Louis seem to be circling around a similar set of like a common set of principles around consistency. Where does Istio's job stop, and where does documentation? Sorry, let me say. Where does Istio-D's job, like the actual software, stop, and where does the documentation start? Can we articulate what those principles look like in terms of a design? Where does that leave us, sort of, as far as the doc? If it sounds like we're starting to come to a consensus.
Maybe let me try to restate it, and Louis, you can tell me if I've captured kind of where you're heading. L7 processing should be applied on the server side. We don't do it on the client side of a connection. And after L7 processing, we still may make a secondary global routing decision that there is no local healthy way to resolve this traffic, so we're going to route it over another multi-cluster hop. When we do that, we will mark the request in such a way that all of the non-repeatable L7 processing has occurred and should not be reapplied to the traffic. And the ultimate destination cluster must respect that marking.
Right, because it is provided by the infrastructure. Yes.
I think that sounds reasonable.
How do we know that a malicious actor isn't just telling you to not apply policies that it doesn't want you to apply?
That's in the spillover case, right, John?
Yeah.
In any case, even locally, right?
Yeah.
I mean,
if we enable this, sorry.
No, go ahead.
I said if we enable the spillover case to allow a waypoint to essentially not apply certain policies, your question is, how do we safeguard against a malicious actor just bypassing that set of policies, right?
Right. Like today, the controls you have is that so someone can bypass my waypoint, but I have a policy that says the traffic came from my waypoint, and I trust that the waypoint applied my policy. But if now someone can call my waypoint and say, actually don't apply policies, And then now I get a request, say, hey, it's for my waypoint. It must have applied on my policies, but it really didn't. Right.
Right. So like one constraint there, John, I think is if we're going to allow waypoint to waypoint, we could require them that they have the same identity. Right. So I'm only going to trust an equivalent.
That doesn't work, I don't think, because if you've got a waypoint doing L7 routing to go to a different service, that service's waypoint's going to have a different identity.
Well, let's explore the limitations of that, Keith, right, and decide if they're intolerable. All right, so 3 clusters. I go from cluster 1 to cluster 2. Cluster 2's waypoint does a routing rule to select a set of backends. Those backends should trust it. The waypoint has an identity, but the backends are only in cluster 3. Right, that's the property we expect. So the backend should trust it. Therefore, they have specified the identity of the waypoint, allowing traffic from it. Now, we're not going to process L7 policies twice, so we're not crossing a policy configuration domain. So the waypoint in cluster 3 is logically the same as the waypoint in cluster 2, because if it was different, it would have different config. Now, that does constrain how things can compose, right? We're not waypoint to waypoint across a trust domain boundary. That is not what we're doing here. Because that literally is, that's more like ingress to waypoint, right? Like now I do want the policies to compose because they are different. And I would not respect the don't process this policy twice part. Absolutely not. So that might be the other, right? Like if we're going to allow waypoints to compose across policy or trust domain boundaries, there is no skipping a policy. We cannot do that. It's only in the case, I think, where they are equivalent identities that we can allow them to assert that config should be skipped. Now, what limitations? Equivalent to trust domains.
Or what if it's, can you explicitly allow another waypoint? Is that a thing we allow today?
No, that's not really something that we have.
Okay, just double click.
Like we allow traffic, right? This is what we allow. We don't have a way of saying, I trust this guy to have applied my policy.
No, yes, I'm saying, do we allow for the workloads in cluster 3, in cluster 3's waypoint, like, can a waypoint trust another waypoint?
So we could have a feature in traffic, right? Which is, don't apply this routing rule if the sender is this identity.
Let me phrase it differently. Can you apply an auth policy to a waypoint that's where the accepted source principle is another waypoint?
Yes.
Okay, so if that's the case, that, correct me if I'm wrong here, if that's the case, that means a requirement isn't necessarily that they're the same identity, but that it's trusted. Am I understanding that correctly?
Yes. Right.
Okay.
So this is an API problem at this point, right? Either we have an implicit runtime feature, which is if same identity, skip all non-idempotent policy, right? As a convenience or as an implicit runtime behavior, a flag, or we have a top level API, right? Which says for these identities, skip all non-idempotent policy. And probably the latter is quite a complicated thing for users to wrap their head around. The former is more understandable because it's just flattening out the network as far as they're concerned conception. Right, because they are the same thing. John, does that sound about right?
Yeah, I'm just not so convinced that like splitting policy is something that can be done. Like if we consider like in sidecars, it's a bit more clear because we already split the policies. Like routing's on the client side and Auth's on the other side. But I'm just not convinced when you have a monolithic thing that there's a meaningful split, and that I can't like say that I have a route that says, /admin is the only thing I expose. That's security sensitive potentially, right? Just because it's not called authorization doesn't necessarily mean it's not expected to be applied.
Right. I mean, there's trying to do it in a fine-grained manner, I think, is probably impractical and insanely complicated. Right. It's more like it's much more coarse-grained than that.
Well, and it's not so much about security versus routing, I think, as it is about what's safe to be repeated and what's not safe to be repeated.
Mm-hmm. Like, just to be clear, right, in the 3-cluster case, if cluster 2's waypoint routes to a pod in cluster 3, it has the permission to do so. Right, I believe.
And it would have that same permission to route to such a pod, the same pod from a namespace sameness perspective in its local cluster.
Right. Right. The authorization, it has an identity that the pod in its L4 authorization policy would allow. And if it was reachable physically and got there, the Z tunnel would allow it. So, going through the waypoint in cluster 3 is but comparing those two things is nominally an accident. It's really just, I'm going through an L4 load balancer.
So in that case, do we just bypass the waypoint altogether, that have the east-west gateway say, if the packet is marked as already having had L7 processing, go straight to a backend service?
I think it's an option. Yeah.
As an option, yeah. Because what Louis is saying is essentially that the waypoint in cluster 2 is effectively the same waypoint that would exist in cluster 3 anyway.
Right. They hold the same identity. That's, as far as we're concerned, like, that's the only thing that we know about that represents a trust domain in the network.
And then we're not dividing policy, I think,
I mean,
objection.
like, if cluster 2 and cluster 3 were on the same VPC, but for some reason you went to an east-west, and then you fixed the config, right, nominally, so, we're on the same VPC, so I'm going to do endpoint discovery. It would go direct. So we want to be careful about not creating silly complications when other network paths could exist, and other network paths can often exist or get created at a later point.
I think I like that because it simplifies the problem, and I think your point is persuasive that from a namespace sameness perspective, if you can reach those backend workloads in the local cluster, you probably can reach them in the remote cluster, just from a namespace sameness identity perspective. They're the same workload, just spread.
They're the same, right?
Yeah.
I don't want to treat the fact that we're going to an east-west gateway as anything other than an accident of network topology. Right? That is just adding complexity.
Yeah.
Now, the waypoint not being in one place or being in the other, we obviously have to physically deal with it, right? And so at a certain point, this is just what's the best way to program this so it works as expected within the constraints, right? Maybe the top requirement is don't do things that we wouldn't do, if the whole thing was a flat network, right? Unless we were forced to do them, right? That's the first property. It's like, don't do things you don't want to do. And okay, then what is the minimum we can do when we're forced to do it?
Well, it seems like it's a safe assumption that if you want L7 functionality, everywhere your service runs has a waypoint. That's effectively already a requirement in ambient.
Yeah, that's one of those we're forced to things, right?
Well, because I'm saying like local cluster traffic to that service, if you didn't have a waypoint and we're relying on some other cluster's waypoint, your local traffic would bypass all that L7 policy.
Yeah, maybe like maybe that's the kind of organizational recommendation that we make. I just want to give that one some thought, right? Like people may do funky things like I have a waypoint cluster. All my workload clusters on the same network. The waypoints are all in the same network. You know, we just got to make sure we don't lock ourselves out of those kind of isolationist topologies. But yeah, maybe. So that one I need to think about a bit more.
So, I mean, when you talk about having a waypoint cluster, I think more about compute than about configuration.
Right.
So you're focusing on maybe the waypoint is executing in some other different compute context, but we would still propagate the waypoint configuration to the server-side cluster and say, I have a waypoint, here is its IP address, here's how policy gets attached to it, etc.
Yeah, I mean, there's some nuance about where the config lives versus where the infrastructure lives, but yeah, I think that's probably accurate enough.
So I want to go to. Oh, go ahead.
Yeah, we could say like if there's a gateway resource in the same namespace as the workload, that's the logical functional trigger. That's what we would write compliance rules around, for instance.
Do we need to implement like a TTL on multi-cluster hops so that it doesn't loop?
We don't need to if we don't go to that second waypoint, because it's a backend. The backend has been resolved, and you're going direct to the endpoints. So there are no
There's a
loops.
scenario where that backend itself could be unhealthy, and we have to do a fourth hop.
No, because the waypoint has layer 7. Well, outlier detection. That's not the right term. It's got global knowledge of everything, and so
if
you
you're
not endpoints.
I think, Mitch, once you're past routing, so let's say you've been through a waypoint once, now you're just L4LBing.
Mhm.
Yeah, maybe you could tolerate one more hop, right? But if your L4LB is not capable of sending you to a place where there is something after a hop, yeah, you have a shitty L4LB and you should stop.
The control plane is sort of going to be responsible for that eventually, eventual consistency-wise, right? It's going to see that this cluster has no local endpoints, and eventually program the waypoint to not send there. The problem with the reason we can't do that on the original client in cluster 1 is because we don't know what the final service is after L7 load balancing. Once we know what the final set of backends is as far as the service goes, so you're not doing L7 again, you can't get into a loop. It's just L7 resolution. And you do know what health is on an eventually consistent basis. It's actually a little bit better than L4 because we do have outlier detection in that waypoint. So in theory, you could have even sort of active health checking sort of behavior and outlier detection.
Sure, but the selection is still L4 at this point, right? You have determined the name service.
Yes.
Right. We just have L7 health checking on it, but that's yeah.
So then with this model, the only kind of outstanding question, as far as I can tell, is one that was already outstanding, which was how do we implement L7 health checking on the client side for the original request? We've never had a clear answer to that, and I'm comfortable not having a clear answer to it today and saying just like that's something eventually we need to build and figure out how to do.
Yeah, I don't know that we ever actually need an answer to that, Mitch.
Okay.
Directly. Health and endpoint checking and endpoint selection, right? You know, we do a lot in Istio, but we could also do a lot better, or other systems could do a lot better, right? And it's maybe something we should look at as an integration point. It's a very complicated domain, right?
Yeah.
So I think we should do the reasonable things. I don't think we need to do more than L4 LB on the client. You know, we could maybe look at improving how we do endpoint and endpoint aggregate health distribution stuff over time. Like we see a reasonable amount of information on it. Coming up with some canonical load balancing scenarios and testing them and having release qualification against them seems like the right approach to that. So we understand what we do well and what we don't do quite so well, and what improvements are required, but I don't know that without that we can make any broad statements about, hey, we need L7 health awareness in the client.
The area where I've always thought of L7 as important is in selecting which of multiple clusters to route to, particularly if you have one that is proximal from a network topology perspective and one that is quite distant. Latency should tell you, but that's an L7, you know, the L7 characteristic of latency should give you information on which backend you ought to select. Is there a better way to do that, like at L4?
I mean, you could have an L4 signal of latency.
Okay.
Right, like we have Z tunnels and east-west gateways and whatever, right? They could ping each other, right? You could do stuff like that. You could do bandwidth delay product calculations. Like with
Actually, the latency in establishing the outer H-bone should be a really reasonable. I hadn't thought about that.
I would not use TLS handshake. I would suggest we use H2 ping, which is what gRPC does, if you want to do a point-to-point L4 latency measurement. But then you have to decide, right, that this all gets very complicated very quickly, right? Because you do like n squared H2 latency measurements. How do you aggregate those, normalize them, redistribute that state, right? It gets quite complicated. How much can you do locally? Locally is not too bad. But H2 pings, right? And we, like with double H-bone, you can even do H2 pings direct to the endpoint through the east-west gateway.
And
right?
the
So
idea is
bunch of power
out of channel, right? So you're doing those sort of constantly in the background and using that to inform the L4 latency decision.
It's passive health checking with latency detection.
Okay.
But it's actually one of the reasons why we used H2 is to do that.
Okay.
gRPC, like even this bandwidth delay product, it actually puts a payload into the ping to calculate the effective bandwidth. I think it's still, certainly when I was working on gRPC, we were doing that.
Okay.
But that's only part of the story, right? Like that doesn't tell you anything about the actual serving latency of the backend. It just tells you how far and how fast is it to a Z tunnel. And oh, by the way, if it's a waypoint, then we have to put that code into the waypoint as well. So there's that. Yeah, that would not be a small project. Let's put it that way. But doable, like absolutely. Like there's plenty of existing art we could point at if we wanted to take that on. But that would be a project measured in quarters.
So it sounds like it's okay for us to move forward without that sort of outlier detection logic or active passive health checking on the back end and just iterate, add that as we go.
Right, and document the limitation, right? You will see in certain situations the suboptimal load balancing decisions being made because of property X, right? Which is when we go across cluster boundaries or waypoint crosses a cluster boundary. Like in general, anytime you're going through a waypoint, right, you're going to have pretty good L7 load balancing behavior in aggregate. It's not going to be perfect if it's a mixture of local and remote endpoints, and especially if the remote endpoints are aggregated. But it'll be pretty good. So like I think for the vast majority of users, it won't be a problem. It's actually just Z-tunnel, right? When Z-tunnel is talking to local or remote endpoints direct without waypoints, that you can end up with a worse set of behaviors. It's pure L4. But you opted in, you didn't put a waypoint in. So like that's how you solve that problem if you wanted to.
Yeah.
Yeah, we just got to be careful of degenerate cases. Like one endpoint locally and 1,000 endpoints remote, and we always send to the local, right? That's not great. Right, so the locality weighted LB when the endpoint distribution is massively skewed is probably the worst problem that we have, not latency stuff.
Well, and we've already got some design in place for weighting of that load balancing, as long as you don't have prefer close enabled. The question then is, when you have prefer close enabled, how do we, at what point, it's not a hard hierarchy. It's not always go local if you can and then go remote. There has to be some sort of back pressure, but that's something that we can get to eventually.
Yeah.
That's pretty advanced.
The prefer is doing a lot of work in that statement.
Exactly.
Okay.
Keith, you've got your hand up.
Sorry.
I wanted to go back to John quickly since he had the concern with the propping up policy on the waypoint. Does this other approach of not going through the waypoint, cluster 3's waypoint, alleviate that concern? Are there other concerns that replace it? I want to see where, kind of do a pulse check on where we are on a consensus basis.
Yeah, before I answer that, can someone walk me through the one request, just make sure I'm actually following everything properly. There's a lot of clusters.
Okay, so cluster 1, 2, and 3, waypoint in cluster 2, client in cluster 1. Waypoint also in cluster 3, service in both.
Yeah, okay.
So cluster 1 goes to cluster 2. Cluster 2 has no backends, so traffic goes Z-tunnel east-west gateway, waypoint in cluster 2. Waypoint says, oops, I have no backends. I'm going to send to cluster 3 because I think there are backends in cluster 3. Mark's traffic saying, I went through waypoint in namespace X. We end up in waypoint X in cluster 3. And now we have to decide to send traffic. The other option, right, so either we end up in the waypoint or the east-west gateway load balances direct to service X in cluster 3 because we know that we've been through a waypoint in cluster 2. One of those two options.
I think it's slightly different because if you have the Z-tunnel is not going to send to a cluster with no healthy endpoints in cluster 2. There has to be an L7 load balancing step.
Eventual consistency says you could end up in that state, right?
Fair. Okay. Fair enough.
So I mean, it kind of makes sense. Like, I think it's potentially fine. Do we think there's no local backends because the user just didn't deploy any there, or because they're all happen to be down, like it's an outage? I guess you said the service exists in both, so that kind of implies it's an outage.
Yeah.
Like, I'm just thinking today we don't do that with sidecars. Once you pick a cluster, it's final, right?
Yeah. So like,
I almost feel like this is something we could say to start with. We don't do the second hop, but it's something we maybe add because it's not required, right? It's just like it's like a failover mechanism.
I think where it becomes more important is when traffic was local. You imagine the case that Louis talked about where there exists no waypoint on the client side. The service does exist on the client side, so Z-tunnel's making a global load balancing decision, and then you introduce a waypoint on the client side to do something very small, like off policy. Now you need to be able to make a global load balancing decision after L7 as well as before. So that's where the double hop becomes important. It's not so much for cases where you go from cluster 1 to cluster 2 to cluster 3, but for cases where sometimes we need to make a global load balancing decision with no layer 7 present on the client side. Other times we need to make a global load balancing decision after layer 7 has been applied on the client side. Does that make sense?
Not entirely. Like, Z-tunnel is always capable of making a global load balancing decision at L4.
Based on endpoint health, service health.
Yeah, it's not as good, but it's still a global one.
But we also need the ability to make it after in the waypoint, right?
Yeah, the waypoint should be logically be able to make as good an L4 decision as Z-tunnel makes.
Yes. So my thought is, like, for instance, in that scenario, you've introduced a local waypoint. You have this beautiful failover mechanism where Z-tunnel could pick a remote cluster. You want to continue to have that failover mechanism. So Z-tunnel says there's a local waypoint. I'm going to go to the local waypoint. Then the local waypoint says, wait. There's actually no way for me to resolve this request in this cluster. That local waypoint then can make the global load balancing decision. Technically, those are two selected clusters. Z-tunnel picked its own cluster and waypoint picked a remote cluster.
Yeah. Okay, so this is not the two waypoint problem. This is the when I cross the network boundary problem. Because if all those endpoints were in the same network, that this problem wouldn't occur, right? Because like the local endpoints are all unhealthy, but who cares? Because there's still other endpoints on the same network that are not cluster local, but they're still network local, and you just go direct to them, right? So this is an east-west gateway problem.
I got lost. Sorry, I don't follow it being
so we go to a local waypoint. right, in your case, and there are no endpoints available for the selected service post-routing. They're all unhealthy for whatever reason. We know that there are endpoints in other clusters. At least we may not know perfectly their health, but we know there's some out there in the universe behind an east-west gateway. So we choose to go to them, some of them, the same way Z-tunnel would. And then since that we're going through an east-west gateway, we've come out of a waypoint, right? If all those endpoints were in the same VPC, we would not go through an east-west gateway, and we maybe have more knowledge about their health, and we would make a selection, and so it would be the same as if they were local, right? And so how do we retain that property?
I guess I'm less worried about that and more just concerned about making sure we're clear that the Z-tunnel can make a global load balancing decision, and then the waypoint can make a global load balancing decision. At each point, we can choose to go to a different cluster, whether we know the endpoints in that cluster or we have to traverse a waypoint, an east-west gateway and don't know the endpoints. Those are sort of the two decision points where that can happen.
Okay, so I think given that we're running out of time, maybe what we should do, and sorry, I am catching up on all the docs post-KubeCon and my travels. Lay out some of the principles we talked about, and then like talk about the different topological permutations and which ones we're okay supporting and which ones we think are just too complicated. And then see if we can.
Sorry.
Right. So that's I guess the single waypoint multi-cluster problem or the multi-network problem really, and then the two waypoint problem. And hope we don't want a three-body problem. The science has taught us we can't predict that.
But am I correct in understanding that we don't see this as like MVP, like minimum for shipping this? Like, do we need? I don't know that we need the L7 bit because to John's point, like we don't. It's minimally useful, not minimally useful. We haven't heard users say they need this in sidecars.
Right.
I hear what Mitch is saying about the local waypoint, but I'm almost of the mind where in most happy paths this is not going to be an issue. So maybe we ship the correctness thing, we just not let a waypoint do a global load balancing decision, and then we iterate in the beta if we hear users say that they need it.
Yeah. So okay, what's the SLA of the simplest system, right? Which is no local endpoints behind a waypoint. Okay, that gives you X number of nines, and people can design around that. Yep. If we then support the waypoint able to make a global load balancing decision, the system gets more reliable. It also gets more complicated. There are some limitations, right? We don't do everything, right? So there's kind of tiers of capability that we get, and we can slipstream them in. Failure is always an option.
It's transient, right? Like if there's no local endpoints, you have to have the service. So either you have the service and just put no compute there, and in that case, you're designing for a specific multi-cluster system, or you have a service, you have compute, but the compute's unhealthy. We expect that on some time horizon that will correct. And so maybe for this first iteration, we just say that's a transient state that the control plane is going to solve eventually when there are no healthy endpoints, and you won't sit in there anymore.
Right, and then like making sure that we can write reasonable guidance to the user. In that case, the guidance is don't put a waypoint where there will be no compute. Users can rock that. There'll be some users may say that's not sufficient for my use case, but for a lot of users, that would be totally fine.
Yeah.
Okay, I think this gives me what we need to keep moving forward on this. I think we're really close in implementation. I know what to build now on a control plane, since we can talk about the data model later. I might just put it in the PR. We can discuss in the PR. But this, I think at this point, we're unblocked for the short time, for the short time.
Now, I do think, and just as a kind of traffic marking so that we know it's gone through a waypoint is still a useful thing to do, even just for debugging and logging purposes, even if we're not trying to authorize or authenticate based on it, right? If we ever ended up in a situation where we didn't want that to happen and that was happening, we would want to log, hey. So I think it's something we should design for. And we should think about what the identity model is for that, right? So we can be reasonably precise about it. And if needed to be part of a trust modeling thing, we could think about that. So I think it's worth maybe carving out a design document for that. Like we have other reasons, right? We don't want loops. We don't want, right? This is a thing in Ingress, right? Like you don't want X forwarded for depth beyond X, right? People run into that kind of crap all the time. So I think it's worthwhile investing some cycles in that. We don't have to block on it, but yeah.
That sounds good. I will try to update this design discussion doc with kind of what we've talked about today and start exploring those topologies we talked about. But it sounds like Keith is unblocked as far as minimum viable is concerned. And then we can talk about traffic marking as well.
Yeah, I mean, maybe just an appendix in this doc is fine to start with, so we could
Okay.
like, iterate on it there for a little bit.
Sounds good.
Um,
Well, thanks for joining, Louis. I feel like you're always able to cut through these Gordian knots really effectively for us, so I appreciate you being here.
I know, John. I think John has had more experience with this particular problem than I have, but it's no, this is all good stuff. This is what we're supposed to be thinking about. Do we have anything? Do we have any post KubeCon action items? Sorry, I know we're off agenda at this point, but I don't.
People
I
are
want to
gonna
strike
start
while the
knocking
iron is
door
hot.
down for migration very soon. That was very loud and clear. I know. Oh, and we need to get the roadmap published. You can see that in the TOC steering channel. I've got a blog sort of drafted.
Yeah.
But we should probably, and I think Microsoft may be willing to invest in migration some as well. As our users are making it loud and clear, they're going to want that as well.
Yeah, I was going to actually ask about that. I think it makes sense. It's not unexpected in any way. I just want to make sure if we're publicly saying like our top roadmap item is migration, that we actually have, a plan to do that and people working towards it. Like the multi-cluster one, obviously, like we're very much on the path to do that. But the migration one, we've kind of just said like we should do migration. So
yeah, we should probably like give users some indication about what the resource is being put towards in terms of like ranking, so that they get some idea of predictability around delivery.
Agreed with that. Yeah. The other one I want to make sure we at some point we talk about is envoy filter on waypoints. There are several users who brought it up, and even a perspective I hadn't thought about when it comes to people like writing APIs on top of envoy filter, like the person who's got the rate limiting controller, and they use that via envoy filter. So that's something that I didn't think about when we sort of said no envoy filter on waypoints. Might be worth revisiting or at least discussing what our ongoing stance is on that.
It's okay. I'll just go around collecting my envoy filter bets. Envoy filter is dead. Long live envoy filter, just like service mesh. Was just to check, because like this was my every single conversation I had at KubeCon was an ambient conversation. Every single last one. If I was an existing user, I was asking how to get onto ambient. I don't think this was just a solo like vendor selection bias. Like it was even just drive-bys and people I was chatting to in the hallway. Was anybody's experience different than that?
There were
some like sidecars or death.
No, I got some like, do I have to migrate? Like I'm on sidecars and I'm happy with them today. Like, do I need to worry about this ambient thing? And I kind of was like, no, like as long as you're happy, stay happy. But that was the strongest use for sidecars that I heard from end users.
Okay, which is
had a random Dapper question, but other than that, yeah, it was all concepts of ambient.
Okay, so I guess working as intended. Were there any other kind of outliery things, or was, from my perspective, KubeCon went exactly as I expected it to, which is reassuring. But were there things that you didn't expect to see or hear?
No, actually, I mean, a lot of it was just knocking on our roadmap. When do we get multi-cluster? When do we get migration?
Okay.
What are we going to do about extensibility? I did talk to a lot of users who are very interested in ambient, but have Envoy filters in their sidecars and want to know
Yep.
what their
Yep.
path forward is going to look like.
All right, then I have given Envoy filter some thought in the context of Waypoint, so I guess we'll have a follow-up conversation about that.
Yeah, we can put that on the agenda for, I think we're meeting again in 2 weeks, right? April 28th.
Yeah, and we could just talk about it in the channel.
Okay.
Okay.
Oh, I got a UDP question. That was the other thing. Somebody, there's a telecom working or tag, I think, starting up in CNCF, and so I was like, I want to move to Istio, but I need like Envoy supports UDP, but there's issues not had anybody address it in years. Is UDP and Istio a pipe dream? Was sort of the idea. So it was one conversation, but I do think,
of course, it was a telco because it always
of course.
is. I guess the one side thing, it seems like the tags in CNCF are getting rebooted.
Yes.
And
yes.
I had an interesting conversation with Tim Hawken where he was complaining a little bit about tag networking being entirely telco dominated when nobody in enterprise cares about what telcos think. I don't want to get in too much trouble. So they were going to reboot it and have it be more kind of workload and typical Kubernetes use case focused rather than be just all about what the telcos want all the time. So we should look to be more involved in tag networking, I think, going forward. I'll check in with Tim about the mechanics of that. But if folks could keep an eye or an ear to the ground on that one.
I think Lynn's already a chair, and I was planning to look into.
Well, I don't know what the reboot means. Like if they just mean completely rebooted and like a new set of people come in to run the thing and whatever. But I think that's in the offing. Having been to tag networking meetings before and found them completely useless, I'm all in favor of this. So, but yeah, UDP, I guess. Why not? Question mark. I guess somebody wants to go and implement HBone in quick and ztunnel.
Yeah, I mean, it's the ingress case is somewhat simple. It's the how do you build a mesh on top of that, right? Like, Envoy can do ingress into UDP fairly simple, but yeah.
Yeah, there are actually better UDP proxies than Envoy though. Like Quoken is a better UDP proxy.
Yep.
So there's also that, right? Like you could go and use another different proxy instead. Was it like telco? So presumably this was video or voice over IP stuff, and not gaming or like turn-based or like those are the two big UDP people usually. So.
Okay. Happy to follow up on the tech network bits as well as we need to get the roadmap out. Maybe a soft deadline of next meeting. Next time we meet in 2 weeks, we want to have something that we're comfortable with for final reviews. I like soft deadline just because we've been trying to work on this for a couple months now and don't have a PR out, so might help out in with priority.
Okay.
Does Solo have someone who will be interested in running point on migration stuff?
I'd have to go.
I don't mean point for all of it. I'd mean for Solo specifically. I know Solo and Google both put their names behind that on the roadmap.
We should.
Okay.
So let me. I'm hesitant to say John because, but that might be the actual truth of it. So
yeah,
give him some leeway on the schedule.
That makes sense.
John did do a lot of work on the tooling that we announced, so yeah, it might have to be him, which also has some implications for the scheduling. Yeah, I'll get back to you on that one.
Thanks.
All right.
All right.
Good to catch up.
See you guys in the chat room and then in 2 weeks.
Talk to you later.
All right. Bye. See you all.